think we're good. No? I'm looking at my OBS health metrics right now. I haven't dropped a frame. 15 seconds, 0 drop frames. I might look like, oh my god, that looks terrible. Wait, no, that doesn't look half bad. That looks okay. I don't know. I think we might be chilling. I think we might be big chilling. To read the chat though, let's see. Can I not have the preview because this preview is going to like drain my own download bandwidth and then it'll like choke on the fact that it can't download this stream. I think we might be chilling though. I think I fixed it. Did I fix it? Is anyone here to tell me if it's like kind of fixed? It seems fixed. I mean, granted, I probably look like I'm like streaming from the International Space Station or something. I turned down the resolution, the frame rate, the cap on the bit rate. Okay, someone in my Discord's asking if I'm live. They said no live. I said I think I am now. Can I tell that I'm live? Let's see. YouTube is telling me I'm live, but also I can't find my own stream. Hey Raj, okay, you found it? See, but if I can't find it, YouTube makes live stream discovery so... Okay, we're live. We're live, and we will enjoy it as long as the internet tolerates it. Let's see. I'm not gonna even try to do a separate, like, set of tabs this time. I'm just going to keep it all on one monitor. I don't have my other monitor, so we're just here on this laptop. Yeah, not Ben traveling, Hassan. Today's like day 2. Like like if yesterday's day 1, today's day 2. We just did a little road trip. It's one last thing before the girls are back in school. And then, yeah, so I'll work from this hotel for a couple days. Let's see. Okay, there's been a lot of stuff happening this week. I also have a lot of ideas for the stream. I'm pulling up stuff that I know we need to pull up. And okay, see, the only problem with me... Okay, occasionally you're going to see my OBS, and it just is what it is, because I don't have 2 monitors to, like, do stuff with this time. Do I even have... I have this. Okay. So we're just going to have to roll with it. It's going to be this. It's going to look weird. I'm trying to make sure I don't have anything open that I, like, shouldn't have open real quick, like any Slack or stuff. I don't think I do. And then I'll transition the thing, and you can all see my monitor and whatnot. Actually, I am going to open... Okay. I still am going to open the other set of tabs. Have you ever used soap and shampoo? Yeah, why? Does my hair look that greasy? Yes, I've used soap and shampoo. What kind of question is that, Hassan? Let's see. Yeah, I also, so if you're noticing it looks kind of shiny. I mean, first off, my hair's just kind of shiny, and my scalp can be kind of oily, but also I use topical minoxidil, which is delivered in oil and makes it like look extra shiny and sometimes a little crusty, honestly. Sorry, I'm still getting that tab ready, or that set of tabs. I think we're good though, so I will transition. Bam. Okay, so we got Minimax H3, or here, let's just go to AA real quick, because I might even see stuff that, like, we would miss otherwise, just making sure we caught, like, everything crazy. Did we know about Seedream 5.0? We knew about Reeve 2.1. Anyway, okay, so let's go to text to video, because that's where I'm a little worried about missing things right now. You can't even go to the LLM leaderboard to know it's recent just because everyone's like making announcements without actually releasing their stuff. We have this guy though, Minimax H3. Nope, that's not what I meant to click. Is this really not gonna work? No? You kidding me? That sucks. Okay, well, there's Minimax H3. Is there anything else? I feel like there's something else for some reason. It's okay though. I have lots of ways to see these kinds of things. Okay, so we can look at Minimax H3. We got a Kimi tech report, right? Because we got the weights. Yeah, we got the tech report. Okay, so we got Kimi, we got Minimax. I feel like we got some other ones. So let me, feel free to paste them in the chat. Let me go to the chat on my phone so I can see what you're saying. Because if I switch back to that tab, we're going to be like, it's going to flip out. Just give me a minute. The fact I can't find myself live concerns me. Like, that should not be, it should not be that hard. Oh, Sam's is on the wrong live stream. Unless, did we die? Did the stream just die? Oh no, we're living. We're still living. Okay. God, that freaked me out. Hey, you can see the stream now, right? This is gonna be freaky. Pengram 4's out? Oh, the optimizer soap and shampoo. Oh, I do know about soap, kind of. I don't know about shampoo. See, I hate that you're making me say these sentences. I guess we can blame the people that made them. Pengram 4's out, really? I missed that. Interesting. Yeah, let's look at that. Okay, I'm going through my Slack to see what else. I'm also trying to see if I can get the frickin' stream on my phone. How are you guys watching? I can't even find myself right now. I'm in my own live tab, and I'm seeing, like, the failed streams, not the current one. This is crazy. Are we serious? Come on. Okay, I've got them. Okay, Pengram 4 technical report sounds good. I'm going to Discord and Slack to grab like all the other stuff I've been planning. I also have some interesting ideas for like I have some interesting stream ideas. Like people are always asking for research ideas, and especially stuff they can do without a lot of compute. And lately I feel like I have a lot of pretty decent ideas. Oh, is there a tech report with this DeepSeek V4 Flash? If there isn't, we'll just read this Reddit post on the DeepSeek subreddit. That's basically a tech report. There's not. Okay. This Reddit post is going to be our authoritative tech report for DeepSeek. It's got 80 plus comments, so it must be doing something right. A friend of mine wrote this blog. We could look at that maybe. It looked kind of interesting. Oh, this, yes. This week was crazy. Did y'all see the 10 advances in mathematics and theoretical computer science? Okay, we should be careful opening too many tabs at once, actually. This Notion is going to kill my bandwidth. Maybe we'll have to read it like a day I have better internet or something. I just realized putting that on would brick everything. All right, let me glance at chat and then let's start to go through some of this stuff. And once we free up bandwidth, we can open more things. So let's do Pangram first because Raj actually asked for that. And then Hassan, did you want me to look at shampoo or soap? Or were you just curious for like personal experience? Can y'all see the text, by the way? Can we here? Let me look on my own phone. Can I read this? It's iffy, huh? Oh no. When I full screen it, you can totally read. Okay. I mean it looks scuffed, so sorry about that. Hey, Noe or Flandre. Ooh, Flandre is one of my favorite League of Legends Chinese pro players. Okay. Present Pangram 4. AUROC. You know, so here's the thing. I use these tools, obviously, because probably all of us get curious sometimes. Oh, it's from UMD? Oh, just, she's UMG. Okay. I get curious sometimes when I see stuff that, like, really smells bad. Speaking of soap and shampoo, when I see stuff that smells bad, I go to Pangram. No, I typically use GPT-0. But it's like I use these tools. I don't know what a number is good or what their benchmarks are or like how toyish they're I don't know anything about them. Right off the bat, the false negative rate's a lot higher than the false positive rate, but that's good considering how the tools need to be used, right? It's sort of like probably the opposite of medical. Well, even in medical screen, you don't want a super high false negative rate, but In medical screening, you really don't want to miss actual cases. So yeah, you're okay with more of a false positive rate as long as there's no false negative rate. But this is kind of the opposite because people get put on academic probation over stuff like this. So ideally, your false positive rate is really, really, really low. That being said, there is something really scary when it comes to developing tools like this, which is like you're going to say, oh, I have this false positive rate, it's super, super low. And so people are just going to look and say, oh, wow, your false positive rate is 0.0041%. So when your tool says my student cheated, there's a 99.996% chance they actually cheated, which is probably not true, right? Um, Not to mention that still leaves, multiple cases per several tens of thousands that didn't cheat. So, or yeah, like six cases per 100,000, I guess. Yeah, like one. That would be 1 in 100, 1 in 1,000, 1 in 10,000. Yeah, 6 in 100,000 cases that they didn't cheat. And when you like do education at scale, like especially when like even at a school like University of Maryland that has like 50,000 students, if everyone at the school does an assignment at the same time, all of them human, 3 of them would get flagged according to their like benchmaxed setting, 3 of them would get falsely flagged, by the way, in this thought experiment I set up where it's only humans doing stuff. Uh, yeah, it has been so crazy though, Hassan. Like, I feel like, I mean, obviously not looking at Pengram 4, but just all the stuff that's happening, like, 2026 compared to 2025 is just on another level. I don't know. 2025 to me, like from start to finish, it didn't feel like as much changed this year. It's been, I don't know. Suddenly we're like doing, well, not we, but like the models are doing math breakthroughs. Not sudden. Okay, so there's people that kind of knew this would happen, but this is actually ahead of even some of the like AI 2027 projections right now. Speaking of AI 2027, I will do that stream. We will do the AI 2027, AI 2040 stream, just not today. What do we want to see from this Pangram report, by the way? What do we want to see here? Like, we're all relatively familiar with these tools, right? Like, it should be able to handle text where the human fully wrote something and the AI fully wrote something. It should also be able to handle one where like the AI edited or the human edited it. Funny enough, my use case tends to be neither of these. Not using the tool, but like when I actually do, if I ever use AI to write, typically I will tell it roughly what to write. I will get it and I will like tear it down, like totally rework it, right? So I do human edited, human planned, AI written, human edited text, I guess, if I use the tool at all. Okay. Yeah, so actually my main use case doesn't really fit into their labels. Because like I wouldn't say my AI just does light copy editing. Sometimes I have it write the entire initial text after I tell it, what we're writing about and what I want it to say and like the arguments and stuff like that. I mean, you could say that mine is AI assisted, but that's not exactly true. In fact, something that I do sometimes is when I'm done, I'll take it to the tool, and the tool will spit out at me 100% human. I don't know. Humanization is auxiliary to blah 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 blah. What do we want from like I guess I'm kind of curious. Yeah, what does the backbone like this tend to be? How big is our detection model? So it's some open weight MOE with a single dense layer for a classifier. It uses hidden states computed by the shared backbone at the final sequence. Oh, okay, just the final sequence position. So it predicts that next token from the text, and that next token is the label that says whether it's text or like human, AI assist, or AI generate. We attach an independent linear classification head for each task. For each task, what? Oh, okay. So each of these are technically different tasks, I guess? Okay, sure. They use the representation of the final supervised sequence position. You said that like multiple times. Why are we saying this over and over? That's funny. Some of these papers, we have to like scratch our heads to see what they're saying. This one's repeated everything at least 2 or 3 times so far. Base model ablations, blah, blah, blah. I'm not getting too much here. Do you have a question about this, Hassan? It's not the most exciting thing I've ever read. Training. We first train a checkpoint supervised On just the segment in humanizer objectives, we then merge the LoRa adapters. Oh, so they're putting LoRa on top of this MOE? Where the heck did they say that? See, they're repeating everything twice, and then out of nowhere, bam, it's LoRa. Seriously, where was the first time they said, oh, base model ablations. We're on small scale ISO compute ablations against blah, blah, blah for each candidate. Okay, they mentioned LoRa here. Where did they first say that, like, we're just training? Okay, it's just kind of mentioned here. I don't know. I don't know if I love the way this is written, if we're being honest with each other, guys. Not that I swore I would stop crying so much about how papers are written. Okay, they say something about base backbone. The last thing I'm curious about is what is the backbone for this? What is the MOE backbone that they're using? Some initialization, right? Whose? Like, what's the base model? Is it some kind of Oh, I guess they say base model ablations, right? Does that mean they try different? Is it like proprietary? Which open weights model they fine tune? I give up. I give up, guys. Okay. Is it an American lab developing Pangram? I think so. I mean, we can find out. Brooklyn, New York. Yep. Yep. Okay, sorry. Let me make sure I'm caught up with chat real quick. I'm looking down at the phone because that's where I have you guys. How is Pangram robust against humanizer tools? Oh, it does mention that. Sorry. Okay. Back to the tech report. They actually did have a blurb on this. We zoomed right past it. Are you guys using humanizer tools? Is that a thing? I mean, sorry. I know it's a thing. Like, come on. I guess I can't. I don't know. I don't know what my opinion is. I wouldn't do it. I think writing is a lot of how you learn, and then it's like your ability to actually express yourself to an audience. The idea of a humanizer tool is pretty funny. Oh, I thought I saw a humanizer tool in here. We'll scroll real quick. I swear I saw, like, okay. As Pangram becomes a more capable AI detector, adversarial actors have greater incentive to evade it. Humanization is, yeah, okay, sorry. For anyone who doesn't know what humanizer might mean, it means like I have AI write the text. I don't want my teacher to catch me, or I don't want my Twitter audience to roast me, so I will pass it through a tool that makes it sound like it wasn't written by AI. Often another AI, by the way. But you could also, I guess, humanize yourself technically. Maybe you could say that's what I'm doing. When I tell the AI what the arguments are and have it set them up, and then I go in and I, organize it the way I want it to be organized, and I write it in my voice, maybe that's humanizing, right? Okay, so humanization detection is a 4-way document-level classification task over human, AI-generated, humanized AI, and mixed authorship. The supplemental classifier is applied when Pangram 4 detects evidence of AI. Okay, so they are only going to even try to use the humanizer when they detect evidence of AIGC. It identifies evasion techniques such as deliberate typo injection, casing changes, synonym substitution, homoglyph attacks, and transformations produced by services that advertise humanization or AI detector evasion. Okay, so let's look up humanize. Okay, so we just read about the definition of humanization. Not very helpful. Wait, they have a model architecture? What? Oh, they do, actually. Yeah, we have a segment level head to predict over segments, a token-wise head, and a mixed authorship head. And we have this humanizer head, which predicts AI, human, AI assisted, or AI plus humanized. So AI plus humanized is its own thing, whereas like our typical token-wise head is just AI mixed or human. And okay, interesting. Humanizer head. Okay. We train a probe on the shared last position logits that learn to differentiate regular AI text from humanized AI text. Oh, interesting. So they treat it as a probe. So letting gradings flow through the base model from the humanized head kept top level of PR equivalent, but concentrated the failures in specific registers. So they actually do a stop grad before they train this head, which is that represented in the architecture diagram? That would have been like really nice. It's not hard to draw either. We have like a standard signal for this kind of thing. Wait, where is it? Hello? Where's the nice benchmark? The architecture. Where's the architecture diagram? There it is. Okay. Yeah, you could have put a stop grad here. Would have been nice. Okay, is that good enough, Hassan, for your humanizer thing? I think so. Yeah, let's move on. What do we want? 10 advances in mathematics sounds fun. Kimmy had a banger, but they are getting accused for KD. I mean, everyone, I hope, is using some kind of knowledge distillation. Raj is just part of the training process. Whether you're using your own traces or someone else's traces, I think barely makes a difference. The only thing is it's hard to get other people's traces. I have little sympathy though, considering how these models are trained in the first place, which is just by taking human knowledge that is out there, a lot of which says don't use me. And I think Anthropic just paid what? What was the settlement? 1.5 billion? Yeah, you're not going to find any sympathy within the actual AI industry for this kind of thing. Like we know that this is our original sin, I suppose. And so when someone wants to cry about getting distilled, that's just how it's taken, right? They're just crying. They can cry. Anyway, 10 advances in mathematics and theoretical computer science. We want to empower blah, blah, blah to accelerate discovery. I believe, by the way, this was done with their closed, like, currently unreleased GPT-6, which, what are they calling it? Astra, I think, is the code name? Or the alias? Let's see. So, this leaked, by the way, before they published it, but I'm too lazy to go find the leak. Anyway, so they want to empower scientists and mathematicians with tools that accelerate discovery. They announced ChatGPT for academic researchers, which provides a bunch of people with free access to the best ChatGPT models. They shared an AI-generated disproof of the Erdos unit distance conjecture. So yeah, for those that don't know, the Erdos problems, I wonder if this is going to pull up AI headlines. It's just like a ton of problems. How many, like, the AI description says 1,000. He would offer, yeah, so during his career, he'd offer payments for solutions to unsolved problems from $25 up to $10,000. How many remain? Does it say that here? Oh, at least 1,000. Oh, but there's not an official list. Interesting. Anyway, a lot of problems, pretty well posed, and so often people point AIs at those problems. They're sharing a selection of 10 results to problems that have been open and have seen no progress on the main result for at least a decade, and they span tons of different things. And these are the 10 problems. I'm not personally familiar with any of them. I've heard that this one is cool, is what I was gathering from reading on like math subreddits and stuff. And I read that this one's crazy because like the proof that it wrote in Lean was like over 10,000 lines long. But I think the tech report itself is just like 30 pages or something. So I guess you could read that. But yeah, high dimensional sphere packing, binary and spherical codes, non-Sophic groups, rigidity conjecture, arithmetic circuit complexity, quantum parallel repetition, closest vector problem, Earhart's volume conjecture, multicolor Ramsey numbers, and extremal number conjectures. I think the part of it that's noteworthy, by the way, is that these problems don't have like really a shared theme, aside from the fact that they were open problems that didn't have, very recent progress. Meaning a few things. So one, it means supposedly that the AI isn't just kind of like taking an alley-oop and then dunking it, right? It's not like the community's been getting really close and then they did some last step, kind of. I mean, they did the last step, but it's not like this problem was definitely going to be solved soon regardless. Also, they're not clustered in the same area, which means it's not just like we tried really, 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 really hard to have like a lattice cryptography solving machine or something. From what I could tell too, the vibes seem to suggest that while none of these problems are necessarily famous, they're a little heavier than just random $25 Erdos problems that nobody's thinking about, is the impression I seem to get. At least, I think what I saw for this one is there was some course someone was teaching where this was like one of the main problems on the syllabus. So I guess that's where we're getting to, and I guess... Oh, this is interesting. Okay, so I've seen a lot of angst from mathematicians around 2 or 3 main points. One of them is just like typical replacement angst, which I guess all of us feel to some extent. The other one is like not, it kind of is attached to replacement angst, but it's like, what's the point of these machines solving these problems if they're going to produce 16,000 line proofs that humans can't understand? Especially if this is how they're solving problems now, how complicated are the solutions to the really hard problems going to be? And will any actual like human be able to understand them? So, and the issues with that are twofold. First, how can we know it's correct if we can't understand it? Two, is it really useful to us if we can't understand it? And I suppose in like the fast takeoff scenario, those end up being useful because the AI can use them and it'll do things, and then you just kind of have to trust it. But still, those things are freaky, right? So I'm curious what they have to say. So the emergence of systems capable of contributing raises questions that cannot be answered by a technology company alone. What is the role of AI in mathematics? Oh, there's a declaration. I haven't seen this. We believe attribution should honestly reflect how a result was produced. Claiming human authorship for a proof generated by AI would be bad. Yeah, that'd be bad. We take responsibility for their correctness while the mathematical arguments are generated by ChatGPT. We hope the mathematical community will engage deeply as AI systems evolve, ensuring... Okay, so this is really nothing. They don't say anything about the issues. I thought they might talk about... What does this declaration say? From 2nd of June 2006. Ooh, these are their potential threats. Current automated techniques can produce plausible but unreliable arguments which are difficult to distinguish from correct proofs. These fast-moving developments put our present system review. Yeah, so okay, same kind of thing we struggle with in computer vision or natural language or just general ML, which is like the AI can be like a fire hose of slop and it's really hard to tell the good from the bad. Honestly, this is what people are struggling with even out just in the regular world with everything, right? Like a guy can generate a 100-line pull request. I have to read all 100. I guess that's a short one. He can generate a 10,000-line pull request, and suddenly I have to like put my name on it, saying, "Oh yeah, I guess that's correct." Or someone I work with can write a 20-page report. They didn't actually write it, right? I'm saying their LLM wrote it, but they could hand me a report that's 20 pages long. Could they have had the time to write that? No. Do I have the time to read it? No. But their AI wrote it, so it's here now. So same problem a lot of us have. Technologies that draw extensively on published mathematical comments undermine the traditional system of attribution because they don't cite the human works. Okay, I think honestly, this happens so much with humans, though. I see so many times, even if it's not intentional, it's like someone publishes a thing that's very, very, very similar to another thing and doesn't cite it. In fact, I would be very surprised if AI does this more than humans. I would bet it does it less, but maybe in math it does it more. Technologies which affect, mainly because, I think, I guess there can be math things that it just learns in its weights and then it doesn't know that it learned it from that place, kind of like when humans learn stuff like that. But I would bet that a lot of its actual solution process, it does come across these highly related papers to the thing that it's doing. And so they're in its trace, and so it knows to put them in, the final cited package. But I don't know. Maybe someone else has proof that this is like a super big problem. Okay, sorry, let me catch up with your things real quick. Can you apply for ChatGPT for academic researchers? I don't know if I could, Hassan. I already have unlimited tokens, though, just paid for by my employer. So I don't know if I have a need right now. Maybe you can apply. 1,217 total problems and 46% have been solved. Ah, okay, cool. So like 650, close to 700 still open. Can we think of these? Oh, hang on, give me 1 second. My family's popping in to grab something. Hang on. Okay, and we're back. Okay, can we think of these 10 advances as brute force solutions or not? I don't think so, no. Let's talk about that in a second. Let me get through this declaration, and then we'll talk about the extent to which it's an interesting thought. How on earth I missed 20 minutes? I don't, because the discovery is awful. I tried to look for my own live so I could read the chat on my phone, and I could not find it. Like, I went to my own channel, and I couldn't find the part that was actually live. Uh, isn't he already having basically infinite tokens from every single last stream? Yes, I have unlimited tokens, no rate limit. So, yeah. No rate limit, infinite tokens. I don't get early access to stuff, though, which sucks. I wish I had early access to things. Imagine if I had GPT-6 right now. That'd be crazy. Anyway, okay, so technologies. Okay, we already talked about this one. Technologies which affect the way in which mathematics is practiced may disturb the current system of incentives. The use of artificial intelligence may become incentivized for its own sake. Yeah, we've seen that happen a lot in software. People just like having leaderboards for who uses the most tokens. And yeah, you might just incentivize the types of problems that AI can solve. I buy this one. Disrupting their mechanisms for hiring, funding, and recognition. Yeah, like if you give a lot more like reward, for example, if you try to say, oh, AI is so productive, how do we incentivize that more? You might give even more funding for the types of problems that you think AI can solve, which means you take money from people that are still working on problems that AI can't solve, which would it's pretty obviously not a great thing to do once you talk about it in those terms. But if all I said is like, oh, AI can solve a lot of math, we need a lot of people to like learn more about how it solves math, then obviously we move money around to those people. But that actually just takes money away from the humans that are still doing like the things that the AI can't do. And so it would slow down progress maybe overall. It's a decent thought. Proper evaluation is endangered if results are communicated through informal channels such as press releases or blog posts, often without any research paper or other disclosure of information. This is a really good point. I think so far we're doing okay, right? Like, where are... I swear they exist, right? Let's see. Do they have them linked, maybe? Read the paper? Read the reasoning walkthroughs? So far, I think... Like, it's very important to call this out. But I think we're not like we're not dead yet when it comes to this. It's good that they say it though, because maybe I don't even remember the releases OpenAI has had before. I remember that the ones around like the Math Olympiad felt really screwy, like a year ago maybe. When was that? I don't know. Whenever they were doing IMO, it was like them and Gemini basically would come out and be like, we did IMO. I think one of them released some evidence, the other really didn't. But it looks like they're hopefully doing what they should for now with this. But obviously, yeah, if they stopped actually posting the proof, that would be really, really bad. Yeah. And yes, it turns math into just a way to market the product, which would be bad. These developments put the autonomy of mathematics under threat. The increasing involvement of technology companies raises the risk that research questions may come to be prioritized because of their amenability. That this rolls back into 3, I think. With university budgets under pressure, if left unchecked, these trends go beyond threatening researchers' autonomy. Okay, I think 3 and 5 are kind of the same. But hey, they're mathematicians, not experts in rhetoric. Let's see. Recommendations. Disclose tool use. Yep. Support the needs of reviewing. Yeah. Adhere to principles of open science. Retain the responsibility for correctness. And you notice they are answering that pretty directly, right? They're like, we helped prepare the manuscripts and formalize the proofs, and we take responsibility for their correctness. So credit and responsibility continue to belong to humans within the math. Okay, except here's a point where they do diverge. The mathematical arguments themselves were generated by our system. It's unclear what the Leiden Declaration wants from them when it comes to this point, because they also say not to lie, like disclose the tool use. It becomes very tricky. Like for the person that in the middle of the FIFA World Cup said, hey, find a counterexample to this Jacobian conjecture, and then it does, how much credit can you really claim? Let's pretend that was literally as simple as it was. I don't remember. I think somewhere you can check the trace, supposedly. If the trace really is that simple and you believe it's that simple, that's all the prompt is, what is the human authorship in that effort at that point? Put effort into proper attribution. This is, yeah, it's important. definitely in the same way that I doubt your ability and you should doubt my ability to find all sources, definitely doubt your LLM's ability to find all the sources. And keep in mind that if it was trained on something, during the post-training, it might be really good at recalling it without knowing that it is recalling it. Participate in public discourse. Stay informed about the emerging technologies. Welcome new contributors. Consider carefully tools. Evaluate the ethical consequences of your work. Build expertise. Oh, this is recommendations for like math people and people that fund research. Build expertise and plan strategically. Take the lead on policies. Maintain standards of rigor. Protect the rights of authors. Insist on appropriate outlets. Support public research labs. Provide frameworks for collaboration and align funding with values. Okay, this is pretty long. That's interesting. Don't believe the hype. Protect the rights of authors. Regulate the industry and invest in public computational infrastructure. Okay, so they definitely do want tools. They want access to the tools. So this is not a declaration from like people that are just like, oh, the tools are bad, right? They just recognize the imbalance of power that the tools can create and the ability of the tools to like shift funding around and to potentially even move the ability. They don't talk about this part as much, but to just move all the ability to make progress on problems from human-led university labs to like mainly machine-driven AI tech company labs. Okay, and these are a bunch of people that signed. Yeah, and then some endorsements from folks. Interesting. Okay, we're not gonna look at those right now. We can keep moving. Let me check on chat. I couldn't find you on X. Are you over there? No, I'm not on X. I don't like it. I don't like what it does to my brain. It says this guy likes AI. Let's put all this AI stuff in front of him, and like half of it sucks and half of it's okay. And it messes with my head. It makes it really hard for me to focus. Okay, we don't get a DeepSeek v4 Flash tech report as far as I could find, so we are looking at this very popular Reddit post. It is definitely shocking the world. But do they have enough capacity? Is it shocking the world? I know they're on AA, so let's go to AA. Let's go to the LLM leaderboard. It's shocking the world by supposedly costing 3 cents per task. Maybe it really does, but I mean, like Luna Max is like 7 cents per task. And what I often find is that these, like, especially when they're first released, somehow these end up being low. Like, or what I've read from people that actually try to use Kimi K3 for stuff, for example, is it doesn't actually end up being cheap like this. That ends up costing very similar. But I don't know. Maybe that's like totally cope, right? Let's see. 3 cents per task would be crazy though. Let's have a look at what the folks are actually saying. Today afternoon, I tried DeepSeek. I gave it a complex task, which I would only gave Sol 5.6 Sol to do before. So it is to finish an unfinished web with a couple of unknown bugs. The previous DeepSeek v4 Pro had pointed me to endless wrong directions, but the new Flash 0731, it debugs all along until it really fixed the issue and fixed all the required missing features. Though cannot tell it is better than GLM 5.2 or GPT 5.5, but I really feel it is on similar level. GLM 5.2. Okay, so we got DeepSeek v4 here. Where do we have GLM 5.2 supposedly? Up here. I mean, supposedly GLM 5.2 is better, but better. What is really crazy, after that 30 minutes work, the 5-hour rolling usage didn't even increase one single percentage. LOL, I feel so good to use a GLM 5.2 level model, but with almost unlimited usage. But then I start worried, once everyone start to rush them, not to mention the new Pro is not yet announced, are they still able to provide it with the current price and speed? We already see GLM increase price and Kimi stops accepting new users. I feel the same will happen to DeepSeek. I really hope such kind level and price of LLM becomes standard. Is DeepSeek able to handle a boost? I want to hear your opinion. It's the model size that can run on hard-based hardware at a decent rate. Is there going to be anything helpful here? I'm mainly looking for stuff like this. I am very positively surprised by this beta. It's better than GLM 5.2 on what I've done today. And yeah, 110 million tokens for 77 cents is wild. That's also a ton of tokens. I'll have 5.6 Sol Ultra work like all day and use a few million. That's a lot of tokens. I guess, is that the strat? Just have a tiny model churn through tokens like crazy, but it's cheaper because it's smaller? Don't worry, bro. There is a leaked closed-door investor meeting from DeepSeek, and the founder said that they're having 70 to 80% margin at this cost. DeepSeek does have some cracked hardware, folks, if you believe what they say about like their GPU util, for example, during training, or like their tensor core utilization is wild. I remember this was like a year ago, but like when most people are around like 20%, they were in the 40s, and maybe it's gotten even better. They really do seem to be hardware gods. If you believe what they say, and if you look at the price that they're charging people for this stuff, it's crazy. DeepSeek does not have a 5-hour rolling usage, so if you say capacity, your provider may not be DeepSeek. Anyway, this model is so small for an inference provider to provide a compatible service. That sounds like OpenCode Go instead of DeepSeek. It'd be really funny if the top level poster is not using DeepSeek. It's a relatively small model. It fits on just 2 H200s for the full experience. Anyone tried this? I tried this with a Preve DeepSeek. Are they talking about the same model? Oh, nice. I made a destructive mistake. My cleanup glob rm rf data deleted all run directories, including the 12 complete artifacts. That's lost paid API work in time. I need to rerun the full pilot with the fixed verifier. Reporting this honestly and restarting now. DeepSeek v4 Flash. My friend actually had Claude do this week. It deleted a bunch of data for him just randomly. He asked it for a summary, and it deleted everything. I thought that was pretty crazy. Okay, that's our DeepSeek v4 Flash moment. If you guys have a tech report, feel free to tell me where to find it, but in lieu of a tech report, we'll just go and see if people say funny things on Reddit. Okay, Kimmy K3. Let's do Minimax first. This one kind of came out of nowhere for me. I feel like a lot of these, you kind of hear little rumors because the teams are so big that you'll hear like, oh, some seed dance is coming soon. Or, oh, like Alibaba has some model coming out. But this one just kind of, I don't know. I wasn't expecting it. I'm looking for more papers real quick because I have some space for that. Just give me a minute. I'm glancing at my Slacks and my Discords. Just because anything that I don't have pulled up, I might forget to do entirely. Oh yeah, we want to. Okay, so the third pre-training axis. Sorry, this. I should be nice. This just sounds funny. Let's take a look, and I'm just gonna try to like ignore. I'm going to like really try to approach this with a empty brain. Okay, I got all my papers from that Slack. Let me go to the other Slack, and then I'll swing over to the Discord and make sure that I'm all papered up. Okay, let's see. Patch forcing. Let's see. I had some friends comment on that. Does that? No. Okay, I haven't looked at the Kimmy tech report yet, by the way. The only thing that I know is that it's they don't use rope. They use nope, which is no rope. Okay, let's look at Cafe. What day is today? We're already in August. Okay, so I'm good on these. Let's go to archive and check and see. Okay, yeah, we got the paper Kunte posted explorative modeling, and Hassan requested energy-based transformers. Okay. Yes, we can do that. Energy-based transformers. Okay, I'm gonna keep teasing y'all with Kimmy K3. We're gonna do that last. This is an older paper. Same people, by the way. Well, same first author, at least. All right, let's get all these ready to actually look at. We'll full screen them to try to make up for my horrendously bad text, my horrendously bad streaming resolution today. Oh, geez, this paper is eating my bandwidth. It's eating my bandwidth like, what's something that people like to eat? It's eating it like soup. No, that sounds stupid. I don't know. It's loading real slow, though. Just bear with me. Okay, what else are we reading? This is why I don't really rely on Reddit. People just talking based on their vibes, a lot of noise. Reef 2.1 is new, but no details on the blog. Oh, so 2.1 is new. What was 2.0 the model from before? Wait, it's not that new. Did we just never went over it in the first place, maybe? I thought I actually did go over this. Are you sure there's something new, Hassan? Same vibe for Reddit. X can be good for that as long as you follow only the right people and don't look. Yeah, I just can't resist the temptation to look at my home tab, I think is the issue. And then even when I follow the right people, you rely on the right people following the right people. And if just a couple of them follow the wrong people, which I don't blame them for following the wrong people, because part of the point of being on X is to know what's happening. It just, yeah, becomes kind of poison for my brain. Parallel decoding distillation for fast image and video generation. Metis memory foundation model. The stream is pretty smooth. That's good. I only turned my bitrate down to 1.5 megabytes per second. Parallel decoding distillation for fast image and video generation. Oh, nice. This one's from very recent. Cool. I like it when you have recent ones. Metis memory foundation model. Ooh, this is also recent. There we go, Raj. We're going to read this not recent one, though. We're going to read this paper from 1,276 years ago. Here, we can look at Reef 2.1 real quick. Oh, Revelations 21. Then I saw a new heaven and a new earth. I should explain the book of Revelation to you guys sometime. I was something of a Christian scholar at one point in time. I could explain all of the metaphors and the historical context and stuff. And then if you ever run into like Christian missionaries in the US or elsewhere, you can be like, let's go to the book of Revelation. Let me explain some things. And they'll be super freaked out, by the way. Especially if you're like in a country where people don't tend to be Christian. They'll just be like, why does this guy know this? Okay, we're releasing Reeve 2.1. This is from a month ago, by the way, but Hassan doesn't remember us doing this. And I kind of don't remember looking at this peach. So there's a chance we didn't do this. What a weird angle. Somehow they cut it off center, yet we get a totally perfect center profile, including like, oh, this looks very weird. That does not look natural. Oh my goodness. You know what's so satisfying? If you guys have never done this, like if you have the capacity to own a citrus tree, like when you prune the branches, it smells so good. And like the leaves smell so good. I always forget until like I go outside to clean up my grapefruit tree or my lemon tree that they smell so nice. Highly recommend. I was reminded of that seeing these random ass leaves sitting here by this peach, I guess. Although it's not, this one's fuzzy. This one doesn't look so fuzzy. So maybe it's a nectarine or something. Anyway, Reeve remains both the top 4K model in the world and the highest ranked independent foundation model lab on both Arena and Design Arena. The model takes back our spot as second overall, trained at less than a tenth of the compute of the labs ranked above and below us. Reeve 2.1 extends the same foundation of controllability. Isn't this the one that's like somehow code-based, right? We can read the layout bed in a second. I don't remember reading that before. Okay, so visual intelligence and layout planning the model reasons about structure, hierarchy, and spatial relationships before it renders. Every element is addressable and editable, so a single region can be changed and re-rendered. Renders at full 16 megapixels, preserving every sharp edge. And multilingual text. Reeve is an independent lab. 2 years ago, our team bet that images should be built like code, layouts, hierarchical structured regions. Our models build controllability into visual intelligence by design. Read the layout bet. Okay, let's look at the layout bet. Oh, wait. I can go to this website? Hang on. I can go to Reeve.com. Reeve.com is a crazy URL to see, by the way, these days. When it's like most of these people are like IO or AI. This one's just .com. Anyway, we made a different bet. We replaced English prose and built a better intermediate representation, a layout. Layout is a structured hierarchical description of an image where every element has a location, a size, a local description, blah, 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 blah. Let's see an example. Is this really the example? No way. Working with the layouts paid off. We built our own unified large layout model for agentic visual understanding and generation. Any combination of layouts, instructions, and images as input drives a layout from its internal thinking trace and then renders the final pixels. Okay, so basically it has like a prompt rewriter, which is essentially a layout rewriter, which can take your layout, your instruction, your image, turn it into a layout, and then it finally renders based on that layout. I kind of want to see what my input looks like though. Get started. No, never mind. Wait, yes, we're doing this. We're doing to try. We're gonna try to do Reeve. What should I make if I'm able to do this without paying the money? What should I make? Okay, I have to do a duo push. It's fine. It's fine. It's fine. It's fine. Okay. What should we make? Wonder. Video world model done better. Okay, sure. Let me pull that up. Video world model done better. Uh, that was freaky. I don't know why I did that. Um, man, you got tons of new papers for me today. Okay, let's do a Reeve. The peach looks like an apple. Yeah, it looked really weird. Um, okay. Continue. Continue. Wait, video models, what? I should have read that. Damn it. Okay. I don't want to try their Chrome extension. Okay. Creations. I'm going to create from scratch. No, I don't want a template. Stop it. Okay, let's click start from a template, but then do a blank one. Can I really not? I don't want a template. Give me picture of dog. Oh wait, no, I got something way funnier. Okay. Um, give me a prompt for an image that will blow Reeve 2.1's mind that it will fail to generate successfully. Okay. Come on. I think we're starting to overwhelm my download. This is really sketchy because we're having to download this 4K dog picture. We're trying to download a dog in 4K from the hotel Wi-Fi. It's just a dog, by the way. It's honestly pretty ugly. Wait, this is done, or have I not really downloaded these, or do I need to pay them? Oh, they're cleaning up. Oh, that's quite nice. The ground curves somehow. Very interesting. Interesting thing for the Earth to do. Maybe we're on a very small Earth, or like at the start of a hill, sloping down gently. That's pretty odd. The foliage is also kind of bizarre if you really look at it in this one. Um, it's unsurprising though. They're actually training with 10 times less compute. That probably just means they're not using much data. So you can do ImageNet stuff pretty good, but if you know what you're looking for, you'll notice really weird idiosyncratic junk kind of in the background. Or like, what's this leaf? It's not actually leaf shaped if we look at it close. Anyway, try this. Okay. That's a cool dog, but I don't think I like dogs anymore. Seeing that picture was enough for me. Sorry. Try this. No problem. Dogs are behind us. Let me bring this surreal museum to life. I'll make 2 takes. Okay. Let's see. Did ChatGPT do it? Did it stump Reeve? Here, the other week we tried to do man versus machine. This is kind of machine versus machine. Let's see if ChatGPT can bamboozle Reeve. By the way, what even is this prompt? I didn't read it. Uh, a single continuous photorealistic long exposure photograph of an impossible 4-dimensional museum interior, viewed simultaneously from inside and outside the same transparent Mobius shaped building. The scene must obey one globe. Okay, what the you generate this. Hi. No. We need to. Yeah. You try it, punk. Like, what even is this? A single continuous photorealistic long exposure photograph of an impossible 4-dimensional museum interior viewed simultaneously from inside and outside the same transparent. What's a Mobius shaped building? Am I stupid? What does it mean to be Mobius shaped? Okay, like a Mobius strip. But what does it mean for a building to be Mobius shaped? I can't picture this in my head. I'm really curious what they'll do. Can Reeve really fail at this? I don't know if it's possible to succeed. The scene must obey one globally consistent geometry and contain no cuts, seams, duplicated objects, or perspective contradictions. At the center, a perfectly reflective glass sphere contains a miniature version of the entire museum, including the sphere itself, recursively visible at exactly 7 levels deep. A woman stands beside the sphere facing away from the camera while her reflection faces the camera and accurately shows the front of her clothing. She holds a transparent umbrella whose shadow falls upward onto the ceiling, yet the umbrella itself remains physically plausible. A spiral staircase wraps around the sphere. Every step is numbered from 1 to 200 in tiny, crisp, correctly ordered handwritten numerals. On step 73, a chessboard is mid-game. All 32 pieces are present. Every piece is anatomically correct in the positions. How are we showing this in one image? What's it thinking? And the position is a legal chess position. A white knight is simultaneously reflected in a nearby mirror from the exactly correct angle. Are these supposed to be different prompts? Am I stupid? Behind this? No, this is the same prompt. Holy crap. One last tweak. Oh, it's almost got it, guys. We're almost there. Just let it do one more tweak. How's Reeve doing? Okay, so... Huh. It did some of it. Can I full screen it? Let's see. Okay, so what did it do? Okay, so there's a chessboard. There's an umbrella. There are multiple levels of reflection in the glass sphere. We're not really getting the Mobius strip idea. We're not. Or are we? The staircase on this one at least, like, what's this? Where's this bottom one going? I feel like we may have thrown it off with the whole Mobius strip thing. Because, like, the spiral staircase should just wrap around the sphere. But we've got this other one here. And every step is supposed to be numbered from 1 to 200. And so it's supposed to have 200 steps. That's kind of implied. A white knight is in the mirror. Oh, God. There's so many details. Like, how do I even check this? I don't know. We're just going to do it on vibes. Which one do we like better? Also, why is there an umbrella up here? That's a crazy artifact. Now that I have these, though, we're going to go back to the... just a second. I want to actually give Reeve a chance to, like, do its thing. Okay, ChatGPT's just, like, dying over here. Let's... Like, I can do templates, right? I want to create. This is an album? No, can I... What if I want to, like, change something? Oh, I can. Okay, okay. Like, how, though? So what if I, like... What if I want a dragon out here? A dragon? And what if I want... What else can I do? Come on. Take the umbrella away. This one is not supposed to be here. Bam. Apply. Let's see if Reeve fixes that. I don't know what I'm doing at this point. This will be the last thing we do. Sorry to distract y'all with this. Ooh. Okay, it's got lots of the Mobius strip idea. It's kind of crazy how far ahead of the game they are, is it not? Like, this is just much better, isn't it? We see the front of her clothing, like the prompt said. 1, 2, 3, 4, 5, 6. I kind of count 6 levels, not 7. But maybe there's 7. It's hard to say. There's cool reflections down in the glass. Although it hallucinated this reflection, I think, relative to what's physically possible. And the clocks didn't reflect really. Normally it does reflections way better than that. I think it freaked itself out with its own prompt a little bit. Here, I just want to see if Reeve can add a dragon outside, and then we'll move on. I know I'm boring you guys. I see the viewer count dropping as I do this disgusting nonsense. What is the strange animation creating the image? Bunch of gradients going back and forth? I'm not sure. It could be the actual layout. Like, these boxes could be the actual boxes containing each item. Because we do see, like, actual parts of the scene sometimes. I think they're just trying to keep us engaged while we wait, though. Like, I don't think they actually have this back and forth diffusion process going. Yep. Palo Alto. Maybe San Francisco. Maybe Palo Alto. I don't know. But I'm going to trust that it's one of the two. GPT is on shrooms. I was planning a hike this weekend, and it started going off reading a 167-page long math paper while I was Googling GPX traces. No more audio. Uh, supposed to minimize that. And then to make prediction. Okay, so it's trained to verify energy value and then make predictions by optimizing with respect to this verifier, minimizing the energy, which is shown in figure 2. Starting from an, if I look at figure 2 closer, is that, no, I don't understand that from figure 2. I'm just going to keep reading the text. Starting from initial predictions such as random noise, they're iteratively refined, they are output by progressively minimizing the energy, ultimately converging to predictions that are consistent with the given context. Okay, for example, blah, 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 blah. Okay. In the case of probabilistic EBMs, this defines a probability distribution using a Boltzmann distribution. Okay. Where Z is the intractable partition function involving an integral over all possible values of X due to the negative exponential. Lower energy corresponds to higher probability, and higher energy corresponds to lower. Yep, this is the part that we get even from what they say initially, right? We're going to have some context. We're going to take a prediction. We're going to predict an energy. We want that energy to be low, meaning that the probability that the thing is related to the context is very, very high. This formulation shifts blah, 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 blah. Okay, okay. While EBMs offer a flexible modeling framework, training them scalably remains an open research problem. So we can do contrastive or regularized methods. Contrastive methods increase the energy of negative samples while decreasing the energy of positive samples due to the cursive dimensionality. Contrastive methods struggle to scale because they must increase the energy of an exponentially higher number of negative samples. An alternative is to frame it as an optimization problem, which avoids the cursive dimensionality by implicitly regularizing the energy landscape, enabling scalable learning. This pushes the energy landscape to be convex surrounding the ground truth solution. Intuitively, this training approach is similar to GANs. During the forward pass, EBMs can be seen as a GAN discriminator by giving an energy verification. On the backward pass, they can be seen as a GAN generator by optimizing predictions through energy minimization to try to fool the discriminator. Oh, wait. No, I still need to see the actual equation before I really feel like I understand anything. We begin with an EBM. Okay. A prior, some initial prediction, and a context for the model. And they want to predict Y. Okay. We aim to find the minimum energy prediction given some input, which we search for using gradient descent. So for every possible training pair, context and Y that we want to predict, we do gradient descent for some number of steps. And we predict the compatibility of our prediction compared to Y by using the model itself. Right? No. It's the most compatible Y given an X. Okay. So we're going to take in X as the context always, and our current Y hat, which starts with some initial random prediction. And at each step, the update is simply to... we do gradient descent on the models, but we take the gradient of the model's prediction and subtract it from... we subtract the gradient of the model's prediction from whatever our current initial prior is, where alpha is some step size. Then the loss can be computed using any standard objective function. For this work, we use the same loss functions as existing papers. So we use categorical cross entropy for language modeling and mean squared error for image denoising. Importantly, this loss is backpropagated through the entire optimization process, requiring second order derivatives. These are computed efficiently via Hexian vector products, which scale linearly with model size. And they did say to see algorithm 1 real quick. So some context, some target, some model that we're training, some number of steps, some size per steps, and some loss. Use gradient descent to get our ultimate prediction for some number of steps. And then compute the loss where we want these two things to be the same. With language modeling, it would be cross entropy. And that would be the loss. And we update E. And it's based on all these different steps. I don't see any stop grads or anything like that. This is the inference. So I suppose the verification starts to happen during inference, right? Where we still have some number of steps defined and a step size. So we're still doing this exact same process, except there's some difference, which is, what is M? Just samples? Oh, like we can try like some kind of test time scaling where we can get multiple potential samples? Right? Because it looks like we just find, like we end up picking the one of these that had the lowest, or like the lowest energy, that was the most probable prediction. I suppose that's what makes it verification, right? We can try many different solutions and then we verify whichever one seems the most correct based on the lowest energy prediction. I think the rest of the paper is going to be really straightforward, right? They're saying it scales better, meaning it like trains faster, it's more flop efficient. It benefits even more from thinking, where its thinking process is this gradient descent algorithm, where it like continuously predicts the energy relative to the current prediction, then takes small steps to get a lower energy prediction. It's kind of satisfying the way that it works, but based on the fact that like we're not using this in current state-of-the-art models, I'm a bit skeptical that this is actually like a superior way to do things, but it might be very good context for this paper. Any questions about this from any of you guys? Sorry, I know I wasn't reading chat. Oh, I'm muted off and on? No way. Am I muted right now? I don't seem to be muted on my end. Am I still muted? I can explain the paper super succinctly now that I'm back. On my end, I'm looking at the audio. It seems on. Let me see. I was at the start of the paper. So what did you miss? I can cover what you may have missed. I am staring at chat right now. I'll stare at chat until everyone knows what they want to know about constantly to know that it's not. Before I was having issues with the hardware. I don't think it's the hardware. I'm pretty sure it's the internet getting mad. Because I've dropped some frames now too. I've dropped like 2% of all frames. So at some point I was dropping frames like crazy, and you may not have realized because we were on the paper. I may have been dropping audio there too. I don't know. Okay, I'm not seeing anything. I'm staring at the mic input right now. I'm not seeing anything. So I'm guessing that when I'm muting, it is just the internet choosing not to upload my audio. Oh man, the audio's been the audio's crazy for that whole paper. I looked away and then it dropped. No. Okay. Oh man. I don't think it's the hard, because I'm looking at the thing that reads the hardware on my end, and I'm not seeing any noticeable cut. Oh, it did drop in OBS and I looked away. Okay, that means it's hardware, right? Oh, I kind of just doxed myself. That's fine. Uh, wait. I'm on laptop audio right now, right? It sounds super terrible. I guess you can hear me though. Yeah, I think you're right that it's either a cable issue or an issue with like the device itself. Right now the computer's not even identifying the device, so that's awesome for me. Um, which I think that's a different issue than normal. There's definitely a cable issue. Like the other day on stream, it was a cable issue. I think I need to replace the cable, or maybe just like rage and give up the mic altogether. I don't know. You can hear me now though, right? It's just it sounds awful and scratchy. Audio's terrible now. Yeah. If you bear with me for a second, I can continue to try to fix this guy. Make him happy again. I mean, you see the same thing I see. We're not even getting Yeti in the options right now. Like we're not even discovering it. Where's microphone? Here, I'm doxing. Oh. No, that would be see, look, no, it should be. Okay, Yeti is the default, I guess. Right? So if I go out of here and I go back to here and I go to the default, is it going to be the Yeti? Oh, I'm back on the Yeti, aren't I? I think I already am. The mic is back. It's the Yeti. Have I cut lately? Or are we like kind of stable? Okay, I'm going to cut it a little bit to move. Bear with me. Okay. It may have cut. It might cut again. Hold on. Okay. We're back? I think so. I hope so. I cannot believe 8 of you are sitting here and watching me be like the most technically incompetent streamer of all time. Did you have questions about this paper? Luckily, I think I cut during the part where I was whining, right? More than the part where I was actually explaining the useful parts. If not, I can do a quick like recap. You'll just have to let me know, and I'll scroll to see if I missed anything other than people telling me that my audio is the worst thing ever. This is good for my metrics though, guys. Like there's so many chats here. The chat rate on this stream is going to be, that's actually probably why we had more viewers. Y'all are chatting more, so it's like the stream is recommended a little more. So more people come. I should try that more often. We should have like 2 minutes of audio disaster every day. Get everyone chatting, and then like it's the strat. It's chat maxing. Chat max with audio disaster. Quick recap. Okay. So my quick recap is we're training this model totally normal. I think that's the easiest way to understand this is to start at the last thing, which is ultimately we have a thing that we're trying to predict, and we have our model's prediction. And if that's language, it's just like our basic cross entropy loss. If that's diffusion, I think they say that somewhere. Let's see. Okay, so I'm just going to go to where they say it in the text. Where do they say the loss? Categorical cross entropy for language modeling and MSE or pixel error for image denoising, or latent error if we're doing latent diffusion. Just, this minus that squared, mean squared error. So losses are normal. That's the key thing here. Another thing that I think will help understand is to look at what we do at inference. At inference, we're going to take a best of approach. We are going to try many different thinkings, many different seeds kind of. We're going to get a bunch of different solutions, and then we're going to take a model that predicts, given some input, is this solution very likely? And we are going to keep the one that is the most likely, the one that's the lowest energy. That's going to be our final answer. In training, we do not take this approach. We're going to try to get one answer. But the way we get the answer is almost reminiscent of like if you ever did adversarial attacks, it's sort of reminiscent of that, where like you train your input with a gradient or something, or what else does it remind you of? It kind of reminds you of a diffusion denoising kind of, or it literally just reminds you of deriving gradient descent, because we predict an energy, we take the gradient, and we subtract that prediction from we subtract the rescaled gradient from our current prediction. So we start with a random prediction, predicted energy, take the gradient, rescale it, subtract that from our current prediction, and that's how we get our next prediction. We do that for some number of steps. That gives us our final solution. So we backpropagate the loss through these however many steps that we had to think, which is a predefined number of steps, but that also means we control the scaling of the thinking itself with the number of steps. And we also control the scale again at inference because we can sample however many different samples we want. We have a built-in verifier though. The same thing we use that builds our answer, which is this energy model, can also be used to decide if our answer is the best answer, or maybe even if our answer is good enough, just if it has low energy. I don't think I can explain very well from the figures, Hassan. I did not find them very helpful and still don't. I guess the easiest way to explain it is our initial prediction can be sampled anywhere on this energy landscape, and we keep taking steps until we end up at a solution that is very low energy. So like the dog caught our first random prediction could be anything. It could be like the dog caught the airplane. That's not very likely. You could catch a plane, but a dog can't. Actually, so that's too likely. The dog caught the counter. Nothing catches counters. The dog caught the counter. Step one, we're going to take some step related to how bad that initial guess was. And that direction is going to move us through the energy landscape towards some minima. So maybe we then go from like the dog caught the counter to the dog caught the plane. Dogs don't catch planes, people do. Then we'll get to dog caught maybe the cat, maybe the frisbee, maybe the ball. And as we go, we'll get towards something more and more probable, which is ultimately frisbee. Or hopefully it's frisbee. That would be if our training's performing well. And then if we're training, we would at that point compute the loss between this prediction and whatever the pre-training text actually has in that position. So low energy means high compatibility with the context, or high probability of being the correct output. High energy means low compatibility, low probability. Does that make sense? No, the prediction likelihood model is the main model. They are training the energy-based model, which is, where do they define it? Thought it was here. Maybe it's not. It's this. This is what we're training. See, so we're training this energy-based model who helps us iteratively arrive to our output. So we return the loss to update the model, and that is the same model that we use to help make the prediction at actual inference, and we use it again as a verifier. So it's both our generator and our discriminator, which is pretty weird, but it's able to do that because it's used as our generator by taking the gradient of its prediction. So when it says, ooh, my verification is that this is kind of bad, we say, oh, okay, well, we'll move a little bit against the direction of badness, essentially. We'll become less bad each time. It can tell you, when it says high energy means very bad. If it says very bad, we say we go in the opposite direction of very bad. If you go in the opposite direction of very bad enough times, you get to something that's hopefully very good. Does that make sense? See, I have less viewers now than I did when we were having all the audio problems. I should chat max more. Are we all good? I think that was about as good of an explanation as I can give. Although if you ask a more specific question, I'm happy to answer. I'll leave it open a little more. We removed the umbrella successfully. It's gone. The one that was up here. And there is a dragon, although, what the heck is it doing over here? Come on, bro. What you doing? Like, I can't even... Is he even... Can I zoom in? Like... Let's download my image. It's beautiful. Come on. Wait, why did I click that? Oh my god, I just triggered a 16 megapixel download in the middle of the stream where I have no internet. I'm so stupid. I keep doing this. Why do I keep doing this? Okay, pretend I didn't do that. Should I even close it? I'm logged in. It's saved. This is saved forever. All I wanted to point out is it seems like this dragon's like he's inside, I guess? He's floating? I don't really get it. And I don't know what this detail is right here, but I don't like it. Like, what is this? And is he missing a leg? She? Could be a she. Is she missing a leg? And what does it mean that she has no arms? Are they supposed to have no arms? Does that make her a wyvern? I thought they're either supposed to have arms on their body or arms on the wings. Not just like 2 legs and no wings. Maybe that makes it a worm. I don't remember. I don't know my dragon nerd crap good enough for this. Here, we can zoom in. Oh wow, it's Oh my goodness, look at this horrible amount of artifacting. Good God, that's disgusting. We can't even generate spindles properly. Maybe I'm not paying them enough money or something? This is terrible. Yeah, I don't know. This dragon looks pretty scuffed, guys. The whole thing is way more scuffed than I thought at first glance. Man, ChatGPT really did a number on Reeve, huh? ChatGPT's image definitely looked better than this one. Okay. Yeah, I did want it to be outside the window, but in Reeve's defense, all I did was highlight that whole box and I said dragon. So I didn't exactly give it a lot to work with. Skill issue, I guess. Okay, so same author as the last paper, explorative modeling. It's a third pre-training axis and end-to-end generation. New paradigm that instead factors the training loop, exploring k-candidate matches between model generations and data and training on the best so predictions commit to modes rather than blurring them. So it's another way to scale beyond parameters and data. In other words, it's a way to make your training longer. Scaling exploration monotonically improves performance across both contiguous and discrete domains. Gains from exploration inclusive scale, climbing from 7% to 36% as data scales and from 13% to 23% as models grow. With the efficiency gains more than doubling at 3 times the compute. Exploration improves flop efficiency by 4 times, sample efficiency by 6 times, parameter efficiency by 47%. So it's basically saying, even though what they're saying is to loop and make your individual per sample training take longer, they're saying that that is so much better that it ultimately improves the scaling. I don't know. I kind of want to get straight to like a figure with the flops and or the wall time. I would love wall time, honestly. I would really love wall time, especially because it seems like there's so many ways for this to get really yucky. In terms of like the flops painting one picture or telling one story, while reality tells a different. However, the thing that should be good for this is I think they're saying we only backprop on the sample on the trace that we want to backprop on. So we can actually do multiple cheap forwards and then do the backward, although we're still having to retain computational graphs on all the samples, aren't we? Or like how much slower are we if we have to recompute those when we actually want to backprop? Which is why I don't just want flops. I mean, they should measure that in flops, recomputation. I'm skeptical. The claims of the paper are so impressive that I'm very skeptical of them as a result. They're just saying that like when they explore, they're able to get lower FID with lower flops. That's the claim. Less tokens. Oh, in this case, it's less data. Okay. So in this case, better performance with less training data. And in this case, I don't actually understand. Oh. Okay, so here it's a bit messy, but eventually we get the same FID at lower training flops because there's like a crossover point. I don't know. When are we going to get to some FED? We do a video model? Okay. Huh. Where are the videos or where are the images? Oh man, they're using some like SAT or some dyno. Like how many of these RAE speed up tricks are they already using that do increase the fit time compared to like regular DIT, but don't really scale to like in the wild problems very well? Oh, this is strange. And why is their inception score so terrible? That's pretty weird. Normally, the inception score simply improves as we decrease the FID. That's very odd. Not that I love any of these metrics, but especially these getting worse is kind of scary. Okay, I was kind of excited about this at first, but now I'm not even really that interested in reading more now. Uh, I think I would be inclined to like have one of my Codex agents poke at it with some T2I and see how it behaves before I spend too much of my own time trying to understand it, because I don't know. There's a lot of ways to train. Evidently, there are a lot of ways to fit ImageNet faster for T2I. What's the T to V though? They have some FED. So what is the? I'm nervous to bump my audio cable. That's why I'm not typing. What is their video training that they're doing to have some Frichet video distance? Is that what FED stands for? I've actually never thought about it. I mean, I've clearly read it at least once in my life. I think the idea is pretty simple though, right? It's some best of K idea. At each training step, the model generates K candidate samples and trains only on the one closest to the data. Implemented as a simple for loop. They say that's the simple way. What's the not simple way? What do they scale? Noe Flandre? They literally put a for loop in the middle of training and they generate multiple samples and they decide to do the gradient backpropagation on the best sample. So they'll predict like 5 noises. They'll compute what would have been the loss and they'll backprop the best one. What is the FID again? The FID is basically how similar the samples they generate tend to be to the real samples. It works well when you have a lot of data because you can get features from like you can get it from a good neural net. You can get it from a kind of mediocre neural net. People often get them from like a VGG or whatever, just because that's historically what we do. Or an inception net. So you get a bunch of inception features, not just later ones, but also intermediate ones. And you compute like the statistical difference between the two distributions to see, does my fake data tend to look like my real data when I look at just the features, where the features project, they hypothetically let you look at the very fine details as well as the very coarse structure of images. Same with FED, but FED is for videos, FID is for images. What I'm looking for right now is to see where the video model is, because I saw some FEDs. Sorry, I'm still looking for a video model. I think we understand the main idea of the paper, and I don't think I'm super convinced by what I see in the results. I'm not saying I would reject this if I were a reviewer. If I were a reviewer, I'd have to look very close. And obviously all these papers are like main conference papers, even if I don't think that they're very important, because I don't think that they're very practical. But, sorry, the only thing I'm looking for right now is where we introduce video. And I don't see it. I'm not going to spend too much longer here, and I'm also too scared to type because I'll bump the cable connected to the mic, and God forbid I lose my mic again. Is training on synthetic image data there yet? People have been training on synthetic image data for a long time, Hassan. Like at least since PixArt Alpha, but probably even before that, people would spend a lot of time in Midjourney and try to get really, really nice stuff from that, and they would post-train on that. That's how you got a lot of models like PixArt and Flux that all kind of had the same like weird AI feel on a lot of their images, where everything was like very fantastical or whatever, because people would pass around the same like 2 million plus sets of images. There was a 2 million set called Pexels, and then there were a few like 10, 12 million image sets from Midjourney. Some of those image models were trained mainly on synthetic data though. And that's been happening for a long time. If anything, I think we probably use more real data than ever, since you can actually like reliably caption it quicker than you could before. Like because training on like just 50 billion open web images where the captions are all nonsense isn't necessarily, especially these days, not going to help your controllable image generation, because everybody expects it to be super nice and follow the prompt and put exactly what you want. If you train on like really noisy data, that's going to be pretty hard. So we've been using synthetic images for a minute. I'd imagine that most people still use synthetic images, but ironically, I don't train a state-of-the-art image model. I tried to train a state-of-the-art video generation model. So I'm reluctant to comment on exactly what all the tricks are these days. Very reluctant. I imagine anybody that's not at the absolute state of the art is probably using some synthetic stuff, but I'm not sure. I'm still, okay, now I'm looking for examples. This is just, How do we have a whole paper about ImageNet? Am I insane? Okay, we have one picture, but I think it's training data. How are you going to write an entire paper about generating images? This actually makes me kind of mad. Like, FID is a fake number. It's an incredibly gameable metric. Like, we know we have to game it, but we look at images. That's how we know if things are good. We look. That's crazy. That's crazy to me. Don't do that. If you're doing a paper in Vision, you show outputs. You don't just show some number from 10 years ago. You show examples. Anyway, Minimax. Okay, Minimax, Kimike 3. We had a couple more papers. I am starting to run lower and lower on time. So we may need to make I can do these 3 fast. I think that's the idea. And then we'll look at Minimax briefly, and then we'll go to Kimike 3, which has been the promise for the entire stream. Let's see. So parallel decoding distillation for fast image and video generation. What is parallel decoding distillation? A simplified and scalable trajectory-based distillation method for, okay, trajectory-based distillation method, does that mean I mean, that can mean a lot of things, actually. PDD, accelerated generation, by predicting multiple denoising steps per network evaluation. Conceptually, it learns a representation of the mean velocity without regressing its derivatives using JVPs. Okay. So is it going to take multiple student predictions to compute multiple losses against the same teacher, or is it going to somehow get multiple teacher steps and then like average that loss? I think that's the only thing I want to know. The parallel decoder predicts the mean velocities for all intervals within a block using a single evaluation. What? Okay, I think that's not what I expected at all. To accelerate sampling from flow models, you propose to learn a parallel decoding model that predicts multiple integration steps in a single. Oh. So assume a pre-trained. Oh, so we are trying to predict all of these. No, but it says it predicts the mean velocities for all intervals. Oh, because this is an interval. So we'll actually take the steps. So it basically predicts multiple steps at once. That'd be pretty neat, no? Okay, defined by blah, 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 and marginals for a fixed time, then a block of size L starting at step n is the set of indices for a state. A parallel decoder with the block size L is trained to predict the mean velocities of all intervals in the next block using a single network evaluation. Okay, so the teacher gives a mean, what? The PDD student approximates the mean velocity across multiple consecutive intervals in a single evaluation. The pre-trained flow model provides the mean velocity of a single interval using ODE solver step. Huh? I'm so confused. Oh, that's why I'm confused. So the student is predicting all of these. So this is the X sub n student. It predicts boom, 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 boom. We are seeing that. Boom, boom. The student predicts all 4 of them at once. The teacher can predict any given one of them, and then the student is fit to have the right predictions according to the teacher at each step, basically. And then that's the PD loss. I'm a little confused though, because this makes it seem like I wish we were seeing like boom, boom, like all the different teacher losses at all the different steps, but maybe we're only computing it for one of them. Let's look at that real quick. It says it provides the mean velocity of a single interval, but does that mean it doesn't evaluate the other intervals at all? Like, does it only do one for any given step? Because that'd be a little weird. Following the student velocity yields the states in the block. One of the states is randomly selected. Okay, yeah, it does look like it's just random. So we predict all of them, but we only are going to check one of them at a time. Maybe that speeds things up, I guess. Okay, I think we got this paper. Sounds like a cool idea, and the distillation is very well motivated. We want to predict multiple ones at once, which is kind of cool. It means, like, regular low steps things means you can only take 1 step instead of 4. But in this way, you still take 4 steps, but with 1 prediction. I like that reformulation of it. I think it's really cool, and training it with distillation makes a lot of sense because the teacher already knows what step to take, and you're just trying to get the student to know to take that step. I like it. Okay. I'm not going to go back to that paper, Hassan, but that is good to know. Is that just a preprint or did it get published? The one we looked at with the exploratory scaling is just a preprint, if that's your question. If you're talking about the paper we were just in, I'm not sure. METIS, Memory Foundation Model. METIS? Okay, that sounds bad. I'm calling it METIS. From external memory to native memory. Ooh, this feels heavier. First prototype of memory foundation models. METIS introduces a new architecture that equips a foundation model with a native memory state. So let's try to understand this. Okay, so I don't. Ugh. So we have some memory right here that's like exists in parallel to our actual transformer stuff. Oh no, this part's the transformer block? What? We have these hyper memory parameters. Oh geez, I want a better diagram. Let's go find one. Okay. Overview of the architecture. Input, response, METIS. Causal language model with METIS. Embed the tokens, input to the transformer layers, which have METIS blocks inside of them. Ultimately, the prediction goes to language model head that predicts tokens until the end. The way a METIS block works is we have our current state. We do our QKV projection. We have this is standard attention right here. We also are going to take that same state that we can project to KQV, and we're going to predict it as some other Q. We are going to do something else to that to get an S and an M. Ooh, I should know what that is. That means something like normal. Hold on. Let's go look at S and M. Oh no, it looks like it is there. Okay, we define a dense memory network. At step T, the model also maintains a query key normalization vector as S. What? The model also both M and S are dynamic parameters updated across different steps. Okay, so M is the dense memory network. And S is the query key normalization vector. So this is a normalization. This is some actual network. Huh? What? 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 How? Huh? What? I don't... That's not what I just read, is it? Good grief. Okay, let's try. Let's give it the old college try. Hypermemory blocks are responsible for updating the dynamic parameters in local memory blocks. Each of them consists of static parameters obtained through mid-training, which remain unchanged during interactions. It serves as the parametric foundation of the native memory storage procedure. It has learnable importance vector, which scores the intermediate activations for adaptive aggregation. In addition, we set the memory key and projection key and value projection matrices, which map the... No, this is not... Dang it. The dense memory network is updated based on... Nope, that's just how we update the dense memory network. Man. I would zoom in on the math, guys, if I thought it was there. I don't think it's here. Ugh. Do I even feel like I understand the mechanism well? I mean, we have these hyper memory blocks, which are these weights that we use here that don't seem to be learnable. They say this is frozen after mid-training. And we have the local memory blocks, which are adapted at the testing phase. Okay, so these are like our fast weights, basically. So this is memory from training, I guess, or like mechanisms that help interface with the memory, right? Like WQ is how we prepare to interact with the local memory here. W aggregate is how we decide what to store, and then that ends up using, again, our local memory. So it's like we have hypermemory that we learned during to train, which I guess you could think of as like how to like keep memory. And then we have the actual local memory that we keep as we work at test time. So test time memory here, 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 here. That ultimately determines what's actually I mean, this is essentially what's actually stored. These are the things that are stored. This is our update for the actual dense memory network and for the normalization that we use at the next step. And it's all determined, it's gated by this learned hypermemory projection here, and by this like aggregation that predicts some importance for retention right here, as well as some other hypermemory operation on what we're actually going to keep in terms of the important pieces. It even says that here, fast parameter versus slow parameter. Slow parameters update stop during the mid-train, local parameters update at test time, and then this is just anything that they add with Metis, which is all the stuff in the memory attention and the native storage, because obviously that stuff doesn't exist outside of Metis. Whereas this is unchanged vanilla stuff, all of this unchanged vanilla, and then same with the green, unchanged vanilla stuff. Nice. This paper made us go through a bunch of what and huh. Are you talking about Metis or are you talking about the last paper? If you're talking about Metis, it's because I swear that they're not putting like all of the actual interactions in the paper. Like I'm assuming that this arrow going to here and here literally just refers to the fact that I multiply Q by M. Or like Q is the input to the M, which is, they call M the dense memory network, but is M, like, they say it's a dense memory network. It looks like a single linear layer. No? I guess that's a dense memory network. This is a lot of parameters though, right? If it's dk cross dv in every block, is that a lot of extra parameters? How slow is this? What are the numbers like? I guess that'll be how we, okay, maybe they do. Okay, they actually do. We didn't scroll far enough. Oh, no, this is theoretical inside of native memory procedure, but it actually does explain. Oh, I said I would look if they explained it, and now they explained it, and now I was bluffing. I was bluffing. I already think I know the intuition. I'm not looking at this right now. I'm looking at the numbers. They can't make me look at that. Neither can you guys, even if you beg. I won't look at it. I said I'm running out of time. I did say that. But okay, I want numbers. Time numbers, memory numbers. Time and memory. That's what we're looking for. We'll settle for flops, but we will not settle for not having the memory. Because this seems pricey. I mean, we're doing test time learning, so we got to even store some gradients and stuff. And we got to do some backprop. Don't worry. I'm positive they'll show memory. It's critical to their arguments that they show me the memory. So there's no way they won't. Every time a paper should show us something, they do. It's not looking good. It's not looking good. I don't even think we got flops. I don't think we even got flops. Oh, thanks for the kind words, Noe. Save your kind words for this paper, though. They're going to need it. Wait. Persistent storage per session. That's not what I was asking for. I mean, it's close. But no, not what I'm asking for. This is not the memory consumption of an AP model at inference. Okay, they just don't have it. They don't have flops. They don't have time. They don't have... Oh. Hold on. Okay, this is the efficiency section. So we should look a little close and make sure that I'm not just glazing over or like just glancing past whatever they're trying to give us. I don't understand how they have lower latency compared to full context. I don't understand what we're comparing here. But I'm also not seeing the numbers I want, which is like them compared to other people in terms of like memory and stuff. I give up. I give up. Okay, cool paper though. Interesting ideas. Okay, video world model done better from Adobe. From this week. So what does their world model do better? Novel camera control representation that exposes camera motion as rendered visual. While pose or plucker provide per image or per pixel pixel ray geometry, they still require the diffusion multiplier for how this coordinate should translate into image motion. I mean, Kinda. We instead render a synthetic 3D scaffold and environment map along the target camera trajectory, directly turning translation, rotation, parallax into frame line visual cues. Because the rendered scene is synthetic rather than reconstructed from an input, the control remains informative even beyond the observed view, enabling accurate and streamable camera control. Okay, so they have more camera control. Memory. Sparse full fidelity memory mechanism. What's their memory? Is it like a point cloud? Is it some text? Is it all historical KV states? No, it's not. That'd be pretty funny though. Decouples memory storage from attention computation. It retains the growing historical KV cache in full fidelity. What? Okay, never mind. It is to keep the whole KV cache. That's awesome. That's awesome. We're going to store the whole KV cache. Use lightweight pooled query key summaries to select a constant size set of relevant memory chunks each rollout step. Okay. So we'll do cheap retrieval on the full fidelity KV cache so that we don't do attention computation of the full KV cache. But we are still going to keep it. Furthermore, we introduce a co-design training strategy, sparse context forcing, that stably activates the sparse memory capability in the student model, where the causal student can smoothly learn to generate content under the same retrieved memory condition it will face at inference. Okay, so they simulate that procedure at inference, basically. They simulate the inference procedure during some stage of the training, a later stage of the training, I guess. Distillation. We redesign few-step autoaggressive distillation around the goal of preserving teacher capabilities in the real-time student. Pretty sure everybody's trying to preserve teacher capabilities, believe it or not. I don't think that's a new goal. The causal student must approximate a bidirectional mini-step teacher with far fewer denoising steps. Yeah, that's normal. Okay. Which leads to both reduced generation diversity and accumulated camera drift. We address these two losses with time-stepwise mixture of students, which increases effective student capacity without changing the streaming interface, and a camera-aware adversarial regularizer, which provides low-frequency control supervision during distillation. Together, so they noticed that the camera got really bad when they were doing this, so they added a camera loss. And then, what's this whole mixture of students thing? I guess we should look. Together, they allow the few-step student to retain visual quality diversity and camera following accuracy. Okay, so right off the bat, by the way, I haven't seen an Adobe model anywhere in the wild, so I'm assuming this is like fine-tuned WAN. We'll see if I'm right. It could be fine-tuned LTX. I should have guessed that, actually. That's a better guess. That's my new guess. My new guess is LTX. We still need to see... run the demo of this world model from its okay, keep in mind, Hassan, I'm at 2 megabytes per second download. And you want me to run a demo. I mean, I will, but I'm just telling you. I don't think it's going to go well for us. I will, though, when we're done looking. Data curation pipeline, open source data sets, self-collected data sets, clipping and filtering, hierarchical captioning. How do you do the camera? How do you say how you do your camera? Unified data. We first collect videos from public data sets and self-render environments, then perform multi-duration, blah, 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 blah. Further enriched with hierarchical VLM captions and camera poses estimated by depth anything. That's so expensive. There's so many cheaper ways to do that, and I think they're better, frankly. I don't know. I shouldn't spill my secret sauce all over the place here. I'm just surprised. But, I mean, they're probably working with hardly any data because they're just fine-tuning something anyway. Let's see though. Let's see how much data, if they even say the amount of data. Do they say the amount? Do they say the amount? They don't. I don't think they do. Dang. That'd be pretty fun. I still want to understand this mixture of students thing. I think that's the only thing from the abstract or from the intro that wasn't immediately like, oh yeah, obviously that's how that works. Wow, that is very, like, strict camera control, geez. Either implicit encoding camera poses of the MLP or rope, or explicit re-rendering reconstructed point clouds. The former is data hungry and often imprecise. Our lattice representation combines the strengths of both. We construct a pixel space coordinate field with a colored spherical environment map at infinity, and a dense 3D lattice scaffold inside. A lightweight renderer converts arbitrary camera trajectories into pixel-aligned lattice videos, and then that's input to the model. Okay. With noisy scene inputs provides, okay, so they're literally going to like render essentially like a very small like lattice space video of the camera moving and give that to the model and say like, here's the camera along with the noisy video. So it increases the input complexity quite a bit compared to like a text-based description of what that same camera is doing. Ooh, base architecture. It's WAN. I should have kept my guess. It's WAN. It's not LTX. It's just WAN. Dang it. I was right the first time. I still want to see this mixture of students. Here we go. I don't want to know about self-forcing. I just want to know. Okay. The causal few steps student auto-aggressively rolls out video chunks under camera controls. The generator roll is perturbed with noisy value by frozen. Where do we get mixture? We specialize different generators for different noisy. Ah, okay. The 4-step sampler uses G1 for core structure, G2 for structure refinement, G3 for detail refinement, final reconstruction, while sharing the same KV cache. Wait. So 4 steps, 3 generators? Okay. 1 generator for step 1, 1 for step 2, and then 1 for step 3 and 4. That's kind of cool. Especially if they're not, like, if we can afford to have all these around. If we can fit them all in memory, it's not too bad. We basically trade off memory for time. We trade off memory for time because we have to keep all these generators in memory, or else we'd have to like load them dynamically and then we lose our speed benefit entirely. So as long as your network is small enough to fit in memory 3 separate times, this works. As I said that out loud, it feels very academic to try to do something like that. But who knows? Maybe there is an efficient way to do this. I don't know. Only with small models, I suppose. Well, what if your students only diverge around a few sets of parameters and then it's just like a routing problem within? That would be kind of interesting. Maybe that's already what they're doing, but I'm not going to look closely enough to know if that's what they're doing. I think I'm going to go look at. I'm going to try the demo like Hassan suggested. Because yeah, I don't care about these scores. Like, cool. That's great. Yeah, I'm sure they wouldn't have submitted the paper if they didn't have some good argument in terms of numbers, right? Let's see if we can watch a demo. Oh, did you guys know that the Flux demo actually is just terrible because like they don't have good taste? I was looking on YouTube and like there's actually really good Flux demos out there from people that know how to make demos. Flux just like chose to make a bad one and put it at the top of their own release, which is kind of crazy. I saw tons of stuff on YouTube that looked really cool from like the creator community. Yeah, we're not. You can watch this on your own, I guess. My hotel internet is not going to cooperate. Ooh, Game Worlds. So they have game, which is neat. And I guess you can watch their own play of their own games. I'll look at this later. Or if you remind me, I'll do it next week when I have internet again. Right now, it's just not in the cards. Okay, we are down to 2 papers. Let me make sure I'm caught up with chat. Okay, I am. Yeah, sorry, Hassan. I did try. It's a bummer. So we'll have to look at Minimax H3 again next week too. Long story short, 15 seconds, 2K resolution, native stereo sound. So text, image, video, audio generation, not text generation. Text input, these 3 out. Maybe actually just these 2 out. These 2 out, I'm positive. And then I think any of them can be inputs. And it's up to 15 seconds at 2K. They can also do 720p. Oh, no. It's 768p because that must be what fits with their particular tokenizer or whatever. They say that they're going to open source it soon. I think you can already pay to use it somewhere because I think I've seen people using it. I don't know if there's much to say about it. I looked at it before. And text to image, text to video with jointly generated audio, all output is native stereo, native multi-shot, which suggests to me that they just have some data that doesn't have the scene cuts. They have the scene cuts annotated, and they just trained the model on that. Text to audio, no separation between voice, sound effects, and music, jointly modeled. Probably, do they even say the architecture yet? I think it's some mixture of transformers, probably. Generalized reference and editing, image to image reference and editing, image to video, audio to audio, audio to video to audio video, audio video to audio video. I think the page is not formatting right, but it's built entirely from real natural data. That might mean they're saying, by the way, no synthetic anywhere. Possibly to answer your earlier speculation, Hassan. Referencing relationships to natural language rather than confined to a fixed task set. Language is the bridge to generalization. I think the main thing that they mean here, by the way, is just like when you have really, really good annotations and you have a really, really good prompted writer, you get much better outputs. And that does match my observation very strongly. These systems are very, very, very reliant on however you decide to treat the text, both the training and inference. Ooh, fuse diverse task types as early as possible and get a good mixing ratio. That's interesting. Omni representation. Introducing multimodal context further broaden what caption needs to cover. We're not just describing the target video, but the relationship to context in the target video. We need to jointly describe any things. This is fundamentally a form of contextual omni representation. We built dedicated models in a full modality understanding pipeline. I assume that means that they like SFT'd very powerful open source VLMs. Wow, most source material requires 100K tokens of inference. It's still down to 4K tokens. Yeah, they have their VAE. That's interesting. That's really interesting, actually. They're on VAE. I wonder if they'll open source that. I am very curious about that part. Anything else to talk about from this one? Just from what they put in this blog? I don't think we have the full tech report soon, so that'll be a great time to look more at the demos. Their tech report is out, which will hopefully be soon. Devil maxing? Oh god, if the microphone is duplicated. Oh, we're like, I'm kind of bugging out right now. I can't get my taskbar to show up. Okay, so you said I'm devil maxing. Can I fix it like this? Does that fix it? Does that fix the doubling? Yay, nay. Blue Yeti needs to be sued. Sorry, Loud. Sorry, Hassan. Okay. I swear I've been looking at... Wait. Not. What about now? Please? Is it fixed? Yay, nay. La 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 la. What if I did something really tricky? What if I was like, what did I say? Is that how it sounds? Is it fixed now? Yay, it's fixed. Why is it like this? I've never done anything with this mic ever. Other than you've seen everything I've ever done with this microphone, you have personally witnessed if you've watched all my content. I don't understand how this keeps happening. I promise. Okay. I keep saying I'm going to replace it, but then I'm like, am I going to spend like $150 and get another mic? I guess I just will. I'm not promising I'm going to have a new one by next week. It is driving me crazy too, though. Maybe that'll be enough to push me to get a new one. I think I'm just in denial that it's broken is the problem. Because like, how could it be broken like this? I like can't believe it. I'm also scared to make videos though. Because at least with the stream, y'all can tell me and I can fix it. If I just record a video like this and then I go to edit it and it's all garbage, I'm going to cry. So, I don't know. Good thing I've been too busy to make videos, I guess is what I'm saying. Oh man, should I have saved this for when I'm the most tired? That was not a good idea. But let's try it. Okay, so bad click. They are trying to prevent us from reading the Kimi K3 tech report. True. Oh, Hassan, do they use RL? How do they use RL? I have heard, didn't I even say this before, that I heard that they use no RL? Was I brave enough to tell you guys that? I'm looking at Discord now. Let me see. I think I may have been so brave. Hang on. I'm looking, I'm scrolling. I am hearing many rumors that Kimi does not do any RL for K3. I said that. I put my name on that. I heard a lot of people say, like rumors and stuff from people that know people, like friends of friends at Moonshot, that there's no RL. Which wouldn't shock me because there's no RL in VideoGen. So, because it doesn't work. It never made sense to me that it worked, if we're being honest with each other. Like my entire early PhD was like RL doesn't work, and then suddenly RL works. I don't know. I'm being super hand wavy, honestly. There's so much more to it than what I'm saying right now. But the idea in VideoGen, at least, is like, if your data is good, what is the point of RL? Like, what are you trying to RL for? We're trying to do a general intelligence, and the RL isn't even remotely general. It's something that we can only introduce at some fine-tuning stage anyway. And so we're simply sharpening our capabilities around like a very narrow set of feedback, which seems like a really weird thing to do when we had, you know, trillions of tokens in the first place. I don't know. They do say, by the way, though, it's supported by infrastructure advances in multiple areas. They do say multi-token agentic RL. So that suggests the usage of some RL around some of this, right? Like they do claim that they use reinforcement learning across general agentic and coding domains with multiple reasoning efforts, enable compositional generation and robust long horizon execution. Supposedly, according to people that I've talked to, they just don't do that somehow in the ways that are the most standard. Anyway, so let's look at the highlights of this are this. This is the big highlight to me. The main one is this. Nope. They instead encode positional information implicitly through the recurrent gating and decay mechanism of KDA. So they've had KDA for 2.6. Is that when they came out with KDA? Or was it even earlier than that? This was the paper where they came out with the KDA. It was at the same time, so they extended the gated DeltaNet to Kimi Delta attention. And the big realization with this paper was basically that Kimi Delta attention already has positional information. So rope just becomes redundant. This is kind of interesting to see because we had, if you remember, we had Inkling, which this was one of the things that I thought was really weird about Inkling, which is that they use relative positional embedding instead of rope, and they find that it extrapolates better to longer sequences. I'm kind of curious in hindsight to look closer at this and see if they also have a similar kind of DeltaNet setup where maybe like they can get rid of the rope because, not because this is working so well, but because the position's already implicitly learned regardless. But anyway, the abstract does mention the reinforcement learning. I want to look closer at what's going on with the RL in this paper, because they do undergo some reinforcement learning, right? They don't share a lot of details. They say mainly that they scale it. And I've heard that like people saying they do none is obviously not fully accurate. So what is the deal with how they do use it is what I want to know. While SFT provides a solid cold start foundation, RL is critical to unlocking higher order reasoning and execution capabilities. Rather than training specialized RL models for individual tasks, we scale RL across 3 broad domains, each encompassing a wide spectrum of subtasks, and train a single expert for each domain at every reasoning effort level. Okay, so they're not going to specialize for individual tasks. Instead, they're just going to have 3 main experts: general tasks, general agents, and coding agents. Scaling RL flops consistently improves the variety of capabilities. Crossing these 3 domain experts with 3 reasoning effort levels yields a total of 9 expert models. And then what are we going to do with those expert models? To mitigate the long tail latency that intensifies in long horizon tasks, paused rollouts are enqueued and prioritized for resumption of the start of the next iteration. Once all K responses for a prompt are complete, they are immediately dispatched by policy, blah, blah, blah. For non-verifiable general tasks, we adopt an agentic generative reward model, GRM, retaining the tournament-style group reward with binary comparisons as in Kimi K2.5. Beyond generic agentic capabilities for enhanced judgment, the agentic judge is required to follow a mandatory protocol. 1. Read the outcome, product or text output. 2. Generate a rubric. 3. Score each candidate. 4. Record the rubric sign scores in a score pad. To mitigate reward hacking, we apply a budget-based, okay, so they try to limit the verbosity directly. multi-teacher on policy distillation to consolidate these domain specialized capabilities across varying reasoning efforts into a unified model. Okay. So here is, I think you're saying no GRPO, no no RL need when you use KD from Fable. Yeah, okay. So Raj, we're looking at the merging strategy right now. So it's not let's see, what was no mention of PPO or GRPO. Here it is, Hassan. Here's how they use the RL that they do use. It's it's MOPD. Is my phone about to die? Oh, it is getting low. I also need to be done in a second. So we're going to look at this, I think, this one part, and then we might come back to this tech report in the next stream. So we can train these 9 RL experts because we train 3 different reasoning efforts and the 3 different task families. And then we are going to merge them. This dense reward signal seamlessly integrates into RL framework. Okay, so they have, for a given domain, optimization is guided by corresponding teacher model among 9 experts. Given a query and a prefix response, the per token APD reward evaluated on YT between the teacher and the student is defined as. This dense reward signal seamlessly integrates into RL framework, naturally enabling infrastructure level optimization, such as partial route training for long arrays and tasks, while we also experiment with more fine-grained top-K distillation objectives. We observe no clear advantage on their convergence speed or final performance in our setting. Okay, so this is how they do the merging. Like this. So whoever I talked to that said no RL, like someone's been exaggerating something. Maybe they meant no RL HF? Or maybe they meant no GRPO. Or no... I mean, this is different, right? Well, except what are these... Like these individual experts, what's the training method for these, right? We have the 9 experts. We have the agentic reward model, but what's the policy optimization algorithm that they use for the 9 individual experts? We can try to look at this more closely later. Let me make sure I'm answering all your questions. If you have other questions, they can kind of guide what we're saying. I want to try to find out more why a lot of the hype around here was not... Like, what is the major difference in how they use RL and how other people are using RL? Is there some argument to make that they don't use an entire type of RL? Or, like, why were people saying that? One part that they're at least claiming is different already is that they did not learn as many RL models, right? 9, I guess, is fewer than what other people use. That's obviously not no RL, though. And they even talk a lot about their RL task synthesis and their agentic environments. I want to look at this more later, for sure. I also want to do my homework to figure out why I heard that rumor and what exactly it means. Maybe the original thing was no GRPO, and it just turns into no RL, even though obviously the RL is a very important part of this, and in fact their RL design is one of the major novelties in this work compared to the earlier works. I'll try to do my homework on that. The Nope thing is pretty cool, though. I wonder if anyone using like gated DeltaNet could be just throwing out rope and they would be fine. Save some compute. Okay, any other questions? No details about the training data. We will resume this next week, Hassan. Oh, wait, yeah, very sparse details there, right? 4 domains. And then vision data is image, text documents, OCR, perception, video, and visual coding data. Using their same pipelines from before, filtered by rules-based heuristics, qualifier-based quality scoring, dedupe. Oh, and they use a rephrasing recipe. I would need to look at Communicate 2 to know about the rephrasing recipe. The vision corpus combines open source collections with in-house pipelines. During training, coordinate supervision is provided in both absolutely normalized formats, enabling precise and robust localization. In addition to classical text caption images, we substantially scale programmatic multimodal data, coupling code snippets with the rendered visuals. Oh, that's neat. You can have the code, like you can just write a bunch of code to render like SVGs and plots and stuff and diagrams and front ends, and then you can have those be the paired things. That's pretty cool. They also talk about scaling law a bit. Like I said, we can look at this more next time, But you're right, that detail about the data is pretty sparse, including we don't even, maybe in the scaling law, they'll say the number of tokens. Or you can kind of actually intuit, right, based on the TPP that they say. Do they give their TPP? Because we know the number of parameters. So even if we know the TPP, we know the number of tokens. Not that that tells us like the number of images or videos or whatever. They might still be kind of keeping that to themselves. We'll have to look more, like I said, next week. I promise. Remind me. I think I'll remember anyway. We'll look at it more next week. Thanks everybody for attending. And I invite you to help me figure out why I heard rumors and even declared early victory that there's not RL, when obviously there is a ton of RL right after the SFT. And even a lot of their attention was spent on unifying the RL in some ways, right? 9 experts, I assume, is a lot less than what some of these other people have been using. Yeah, maybe it's just no human feedback in that loop makes it unique. Maybe no RLHF is what was said at some point, and that made it back to me as no RL. I don't know. Anyway, take care. Until next time. Bye. Thanks for tolerating the super low quality stream, including the microphone constantly like betraying me.